So I come from Yahoo. I was at Yahoo for 8.5 years. And during my last 5 years at Yahoo, I was responsible for a business intelligence and data analytics team that had to analyze data from a number of Yahoo's key properties like Yahoo Finance, Yahoo News, Yahoo Search, Yahoo Mail, etc., etc. And my co-founder, Jeff Hammerbecker, co-founded Cloudera with me, and he had a very similar role at Facebook, where he also ran a very big business intelligence and data analytics team at Facebook. And we both had the same headaches with the data that we had. And we were looking for a new aspirin to cure these headaches. And the headaches really are characterized by 4 things. And that's what I say, what I claim is the definition of big data, are these 4 things. The first one is data that's growing every day. Right, so every day I have more data than previous day, and it just keeps growing with that trend. Second is data that has many types and many formats. It's not just a fixed relational format. It's all over the place. It's XML, JSON, Apache log files, web crawls, images, videos, you name it. So many formats, and even within a given format, which is the third kind of headache. The schema of that data, the structure of that data is evolving all the time. So that the schema, you're getting new attributes, you're getting new dimensions, you're getting new facts, and you have to have a data model that can evolve very quickly. And then last but not least, both of our organizations at Yahoo and Facebook, we're not looking at data simply as a something that feeds into a dashboard that you show to the chief financial officer once every quarter, but rather looking at data as an asset in itself. And that's not a technology thing, that's more a cultural thing. Like companies now across the world are evolving from looking at data simply as a numbers on a report to being a true asset in itself that needs to be leveraged in new ways. So these 4 things, data that's growing very quickly, data that has many types and forms, data that has dynamic schemas that are evolving all over all the time, and the need to leverage data as a true asset is really what defines big data, in my opinion. And these were the headaches we had. That was in 2004, 2005, 2006. We looked at many solutions out there, from the database space, from the high-performance computing space, from the storage space, and none of them was able to fulfill our needs. None of them was a pure cure for the headaches we had. We always felt we were constrained. We always felt there was this ocean of big data out there that we had, and all of these technologies presented a small straw that we have to use to, and we didn't want to use a straw. We wanted to jump in and swim in the ocean. So, and that's when we came across Hadoop, right? We came across Hadoop, and Hadoop was born around that time, and we saw how it truly solved all of these headaches. So, what Hadoop is, in a nutshell, actually, let me ask first, how many of you know what Hadoop is? Raise your hand. Okay, that's very good. So maybe I should skip the slide. So what Hadoop is an elephant, right? You guys know this very well. So Hadoop, the elephant Hadoop, the nice yellow elephant comes from the initial co-founder of Hadoop, Doug Cutting, and Mike Caffarella is the other co-founder. Doug, his son, was 3 years old, 4 years old at the time, and he had a nice elephant plush toy, and out of the blue one day his son started saying the word Hadoop for that elephant, for the toy. And his dad picked up that name, and he used that name for the project. And now his son is about 11 years old, and he's very proud of his contribution. But what Hadoop truly is, it's a data operating system. And that's how I like to define it. I like to say it's a data operating system. And I like to remind people what is an operating system first. So what is Windows? What is Linux? What is Mac OS? At the heart, there are 2 things. At the heart of any operating system is 2 things. Even DOS, if you go back to 30 years. These 2 things are the ability to store files and the ability to run applications on top of files. That's exactly what Hadoop is. Hadoop is a system that lets you store files and run applications on top of files. With the main difference being it does that across a cluster of machines, so it joins many, many machines to provide the abstraction of one large machine that knows how to store files and run applications on top of files. That's it. That's exactly what Hadoop is. And the two systems in the heart, as you know, is the HDFS, the Hadoop Distributed File System, and MapReduce. And then the key benefits it brings are the benefits that I described as headaches a few minutes earlier, which is the ability, the flexibility, meaning the ability to store data of any type, ability to have schemas that are changing all the time, dynamically evolving all the time, and the ability to run more than just queries. So SQL is great, and Hadoop runs SQL, by the way, using Hive. But SQL, is, as you know, is a non-Turing complete language. You can't do everything in SQL. I want to be able to do other things that don't fit in that model of simple queries on top of my data. And Hadoop has that capability. It has the ability to let you go beyond just SQL, and that's very, very important. So flexibility is by far the main advantage that Hadoop brings, and the main differentiation it brings compared to other systems out there. Scalability of Hadoop is also very, very significant. And scalability here is not just simply scalability of the infrastructure from a technology point of view, meaning the hardware and the software can support more bandwidth and more computation power, but also scalability of humans, meaning two things. One, developers that write queries and jobs that run on 3 nodes don't need to change them when they want to run them on thousands of nodes. With traditional technologies like relational databases, you have to re-architect your query. You have to give hints, you have to repartition, you have to create new indexes. In Hadoop, the same job you did for a few nodes runs on thousands of nodes. You don't need to re-architect anything. Same thing with system administration. Hadoop has so much smarts in it that predicts and routes against failure of hardware and failure of network, so that you only need one system admin for every 1,000 nodes. Maybe 2 system admins in case something happens to the first one, but that's about it, right? So scalability of humans is very, very important. And then last but not least is economics. Because of the smarts in the software, you're able to use the cheapest hardware out there. You don't need hard disks that fail only once every 10 years or 100 years. You can have hard disks that fail all the time. That's fine. The software will deal with it. And that brings down the economics of storage to a level where you can keep all of your original data for much longer, which is something that most enterprises need today. So these are the 3 kind of core powers of the system and what it brings, with the flexibility and agility being the key differentiator. No other system out there, like relational systems, they all require you to have the schema before you can do anything. You can't load any data into them before you define your schema. If you try to load data that doesn't fit the schema, it gets dropped on the floor. Hadoop does it the other way around. Hadoop lets you upload anything you would like, and then at runtime you apply the schema that you would like. And that brings all of this flexibility to the system. So I had a slide on the history. I don't want to go over the history in a lot of detail. Just to remind people, the original papers came out of Google, the Google file system, and the Google MapReduce system. They did not publish the source code. They published papers describing how to implement the concepts. And that's where initially Doug with Mike Afrilla, but later on Yahoo, with a very huge investment of engineers, took these ideas and created the system, and we're here today. That's kind of the history very quickly. Now, this slide, the key point I want to make with it is it's more than just Hadoop. So Hadoop is the kernel. It's the kernel of your operating system. But same thing, you don't just get the kernel of Linux. You don't just get the kernel of Windows. You need all the things around the kernel that make it functional, right? For example, in the OS world, you need device drivers, you need X Windows for UI, you need security and credential authentication, etc., etc. You need many things around the kernel that make it really functional. And the same thing is happening with this data operating system today. Hadoop is the core, but then you have things like EdgeBase on the right that are built on top of Hadoop. Again, another paper from Google, the Google Big Table, is the foundation for EdgeBase that lets you do low latency and lets you do transactions. You have, for example, on the left, you have Apache Flume and Apache Scoop that make it very easy to integrate Hadoop with other systems, to copy data from and to Hadoop. You have things like Apache Hive and Apache Pig that make it much easier to write queries on top of Hadoop, so you don't have to go and learn Java MapReduce from scratch. You can use higher level language abstractions, and they get compiled into MapReduce for you. You have Apache Uzi, the job workflow that lets you create a workflow of jobs that run in a specific order and get retried when they failed, etc., etc. You have Apache Mahout, which is a data mining library built on top of MapReduce, implementing some of the most popular data mining algorithms for you, so you don't have to do them from scratch, etc., etc. So, but the key point here is it's not just Hadoop, it's Hadoop with all of these things around it that make this true functional, highly capable data operating system for you, with Hadoop being the kernel at the heart of all of this. These are some of the key things in CDH4, but at Hadoop at large as well. It's a very long list because it's not just Hadoop, it's Hadoop and the projects around it. But if I were to pick two key things that happened with Hadoop over the last couple of years that really made it much more reliable and functional, it's the first bullet point there, high availability. Is Hadoop now does not have the single point of failure in the name node, which was one of the key issues with Hadoop. It's very hard to describe in detail unless if you know the architecture, but that issue has been resolved now. So there is no single point of failure for the storage system right now. Same thing with edge-based now. There is more functionality for doing replication across edge-based clusters. So you can have more than one cluster, which is very important for disaster recovery and business continuity. The other key thing, improvement, actually is performance. Hadoop performance increased significantly over the last year, anywhere from 20% for throughput intensive jobs to 100% for latency sensitive jobs. So significant investments in performance. Scalability also now with MapReduce 2 Yarn, and I assume Eric will cover that in more detail. And with the name node federation, we're able to go beyond the limit we had of 2,000 to 4,000 nodes per Hadoop cluster. That now is broken. That limit, we can go much bigger by leveraging these two technologies, Yarn and federation. So the key point of this slide, and you can look at them at the rest just for the purpose of time here, is the system continues to evolve. It continues to evolve. There is lots of investment from many companies into making the system much stronger, much more reliable, much more available, and much more scalable and performant as well. And again, not just the core, but everything around the core as well. So with that, I just want to touch on the future briefly, and then Eric will give you more details on the Hadoop layer itself. But the future is about these 5 dimensions, right? We want to be able to collect data more scalably, more reliably. We want to be able to store that data. We want to make it searchable, so you can search the data that you stored easily. We want to be able to run multiple frameworks, not just MapReduce. MapReduce is good at many things, but it's not the answer for everything. So workload management for processing data. Analyzing data, we need better metadata management for the data and lineage, and where did the data come from, how did they get translated, etc., etc. All of these are gaps that we're working on. And we want to be able to serve data interactively with very low latency. So these kind of the 5 mega themes of how we evolving this whole stack going forward. And again, Eric will give you more details. So with that, before I conclude, I just wanted to cover briefly 3 things about kind of the intersection of big data with cloud computing. The first one is I very quickly want to tell you the story of the Cloudera name. Obviously, Cloudera, cloud era is what it stands for, like the era, the age of the cloud. And our initial pitch to our investors that was in 2008 was we were going to build this nice cloud service where people can upload all of their big data, we do the computation, and we give them back answers. And very quickly, Cloudera had to pivot away from that business, from that kind of solution, because big data does not lend itself very well to external clouds right now, today. It might change in the future, but right now, what happens is most of the large enterprises that have big data, it's the logistics of moving all of that big data, not the security concerns actually, it is the logistics of moving all of that big data from their internal networks to external clouds is a big inhibitor for them. So all of them over and over again were asking, give us a solution that we can run in-house. So Cloudera shifted from being a cloud services company to an enterprise software company that gives you enterprise software that lets you build your own cloud infrastructure internally. That said, we kept the name as Cloudera because people remember the name, so we didn't change the name. Now, will that change over time? I think yes. I think eventually companies will get over the logistics boundaries. With newer projects, we see many companies starting in the cloud. We made sure that our distribution works in the cloud, so you can deploy it on top of Amazon EC2, you can deploy it on top of Rackspace and other cloud providers. But today, the majority still is inside for these reasons, the logistics of the data, but also because they want to have the system running beside their Oracle system, beside their NetApp system, their EMC system. So there is this affinity of the big data, and big data has lots of momentum. It's very hard to push it once it gets somewhere. So that's kind of external clouds. With internal clouds, just very briefly, internal clouds, I mean virtual infrastructure. Virtual infrastructure has a significant issue today, which is most of the virtual infrastructure implementations depend on central storage, right? So they want to run the VM images in the servers, and then they want to mount the storage from a central storage area network, and that conflicts with Hadoop. Hadoop really wants to use local storage to optimize for data locality and get much more higher throughput from the local disks for the job you're running. So while you can run Hadoop today on virtual infrastructure in the internal clouds, the performance could be anywhere from twice as slow to 5 times as slow, depending on the storage solution that you have. So with that, I would like to pass on to Eric. Thank you very much.